Everyone, Mr. Rainsford here. We're looking at lesson 1.3, which deals with describing quantitative data with numbers. In 1.2, we looked at displaying quantitative data with graphs. Something really important covered in 1.2 was SOCs. Shape, outlier, center, spread. Now, shape we were very specific with. We talked about being roughly symmetric, mound-shaped, left skewed, right skewed. But when you were describing distributions at this point with outlier, center, spread, you're pretty vague. You would say there's potential outliers, maybe here and or here. The center is approximately this or near this. The spread, you might say the range is this value, or it varies widely. When you're going through, we were very vague in 1.2, and when we look at 1.3, we start to now get specific. You start to be able to calculate outliers, center, and some values for spread to help us out. And so that's where we're starting with our 1.3 as we're going there. So let's start with our measures of center. We have the mean and we have the median. The mean is the most common measure of center. It's the arithmetic average. You take the sum of the observations, divide by the sample size by the number of observations. For samples, we use X bar to represent the sample mean of it. The formula itself uses the Greek letter sigma as shorthand for add them all up, or the sum of the following numbers. So if you are kind of showing work for the mean, you just kind of list off the first two, but dot, 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 the last one, divide by the total number of observations. That's the mean. You're really familiar with that one. Just be familiar with the notation of X bar for sample size, and you're starting to get used to the idea of the sigma for Greek letter for the sum of. The median is another measure of center. Now, the median is the one that we've looked at before with 1.2 when we looked at stem plots. It's the midpoint of the distribution. It cuts the data in half for us. And so when we're doing this, we want to make sure we put it in numerical order. So the first step is arrange all observations from smallest to largest. If the observations are odd, the median is the center number in the list. If the observations are even, the median is the average of the two. And so that means it's not, even versus odd numbers in the data set. You can use this position shortcut to help you out for it. Is if I have a sample size of 50, well, to find the position of the median, we use capital M for shorthand for that. I would add 1 to that, so the median position would be 50 plus 1 and divide by 2, so 51 divided by 2, 25.5. So it's going to be between the 25th term and the 26th term, and I'm going to find the average of those numbers on it. So that's the median. Let's try now and look at an example of it. So when we're going through and we're asked to find the mean and the median, this is already worked out for you on this case for the video, and I'm just going to talk through it. Is you are given 20 randomly selected New York workers. You're looking at the commute times, context in minutes. There they are. There's all 20, and you can see based off the information given to us, it's not in numerical order. And so we're going to find the median. We're going to put it in numerical order. For the mean, we can just add them up and divide by the total in whatever order it gave us to. And you can see that here. But again, notice the notation. Notice what it's having us do. We're using X bar for the sample. On it, we added them up, divided by the total. There's our mean. For the median, again, you have to put it in least to greatest order. So instead of rewriting all of them up here to put it in least to greatest order, what I'm going to do is I'm going to organize them in a stem plot on this side. So you can see that's done on this left side. And that's important because this is 1, 2 right here. So when you were putting them in numerical order, when we arrange them in a stem plot, it would actually give us information to describe the distribution as well. I mean, if I would imagine turning that the other direction, I would see that it is skewed right for this information. So I can actually even describe the shape on that. So if you're putting them in least to greatest order, we have the ability to do that and also look at the shape at the same time. So in this case, if I want to look at, we'll look at median position. It's shown there, but I want to find it is my median position is 20 terms, 20 observations. I'm going to add 1, divide by 2, 21. So it's the 10.5th position. So that's why we looked at in between these. It cuts those in half. So we take the 20 and we take the 25 and we divide by 2. We find the average of that. And so 22.5 minutes. Notice we're labeling, we're not just saying the average is 31.25, the average is, the median is 22.5. we're putting context. The mean is 31.25 minutes. The median is 22.5 minutes of commuting time of 20 randomly selected New York workers. So that's mean and median. In this case, it was an even number of observations for it. So if we look at this one, here's an odd number. It's blue. It's not on your notes, but I'm still going to talk about it and go through it. Again, sample mean already done for us. X bar, you add the numbers, divide by, in this case, 15 McDonald's beef sandwiches. So 15 is our, we're looking at amounts of fat in that. 15 is our sample size. So we add them up, divide by 15, boom. Again, you see the X bar, you see the context. We're not just giving the number, we're telling what that number means on it. Now this one has an odd number. We had 15, so my median position for this one would be take the 15th term, add 1, divide by 2, and I get 8. The 8th term in least to greatest order is my median, and we can see that. Let's count. 1, 2, 3, 4, 5, 6, 7. Yep. 26 is the middle observation in this case. So that means the median McDonald's beef sandwich contains 26 grams of fat. Context. So even number of observations, odd number of observations for median. Now, if I want to compare mean and median together, this is one that's a really good slide. Don't get them confused on it. They're both great measures of center in different ways, and they're useful in different ways. So don't confuse the average value of a variable, the mean, with its typical value, which we call the median. If we're looking at a roughly symmetric distribution, so right here, if I'm looking at a roughly symmetric distribution, the mean and the median are close together. And we'll look at the middle, like we'll call this approximately symmetrical, roughly symmetrical. It's mound shaped. And so when you have one that is roughly symmetrical, the mean X bar is roughly the same as the median. They're going to be close together in that case. If the distribution is exactly symmetrical, perfectly symmetrical, in that case, the mean and the median are the exact same. X bar equals your median. If I'm looking at II in the middle there, I'm going to call that roughly symmetrical. I can't prove it's perfectly symmetrical, so I'm going to call it roughly. Now, in this case, what we want to do is B and C, they mean nothing to us. I mean, boom, boom, cross them out. They're not there at all on it. I only want to focus on that A position. That A position would be the location of your X bar, and it would be the location of your median. I'm going to say approximately because I don't know if it's perfectly symmetrical or not. That's where they are. And by the way, it being the peak, the mound, the apex of it, the high point of it, that is your mode as well. So in that case, your mean, sample mean, your median, and your mode are equal to each other. And that's for an approximately symmetrical mound-shaped graph for it. So we ignored B and C here. Now I'm going to go over to the I part. And I'm looking at this one. This is a right skewed distribution. The tail is being pulled to the right, and so it's right skewed. Now, if I want to figure out where's my sample mean, where's my median on it, we're going to kind of analyze it. Is the A position, that is the peak of it, that is the highest point. That's the one that occurred the most. It's the one in the dot plot that bam, 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 bam. It was all the way at the top. So A would be your mode in this case. It's the one that occurred the most, so it has the most there. Now we're looking at B and C. Well, if we look at this, then I'm going to help you out with this, and something we're going to learn in chapter 2 is the median is your B and the sample mean is your C. So let's talk about the median. The median takes the data and it splits it in half, perfectly in half. It's the middle position. And so it's going to do the same thing when it comes to a distribution as well. The median is going to split the area in the distribution, the area underneath the curve, perfectly in half. And so that's what B does. B there goes through and it is the middle part. The sample mean, X bar, is what we call the balancing point of it. We're going to get into that in more detail in chapter 2, but to help you realize why X bar is more in the tail is because you have some observations in that tail and it's going to pull the mean towards it. The median is more going to stay in the middle on it. It doesn't fall into that idea of being pulled into the tail for it. It's going to be more resistant than the mean is. And let me move my face out of the way here. And if I look at this one, here we have its left skew. And we can kind of follow the same idea. The highest point is your mode. In this case, look at that's a little bit longer of a tail on that side. So, I mean, this is your median and this is your X bar. Do be careful. The X bar, the sample mean, gets pulled towards the tail, but doesn't get pulled way into the tail. It's affected by the number, the values in the tail, but it's not strongly affected by it. It's going to not get all the way in there. It's still going to be in that middle part, because let's say it's like a balancing point for it. The median, though, is going to still be closer to where it was. It's more resistant to those on the skewness of it. So measures of spreads. We've done center. Now we're going to do spread. You looked at range in 1-2. We're going to focus on IQR, interquartile range, in 1-3. And you're also going to focus on standard deviation. And Mr. McNichols will be hitting the standard deviation part of it in a future video. I'm going to focus on here for spread. Now remember from 1-2, range is a number. You're not going to say the range is from 2 to 9. No, you're going to tell me the range is 7. It's a number. And the IQR is the same way. The IQR is going to be given as a number for it. So do keep that in mind as well. You're not going to give me as from this to this is the IQR. No, the IQR is a specific number, just like the range is. So what is the IQR on it? And I'm going to keep my face up here so we can see everything down there. Is the IQR helps you. A measure of center alone can be misleading, and that's kind of what this is meant to show you. Is if you just give me this measure of center, it could be misleading because it's being affected by that tail on it. So we want to look at spread as well. And so we're going to look at some different measures of spread, and this one is IQR, interquartile range. Now that is related very similar to the median, and you can look at the steps here. You're going to range it in least to greatest order. You're going to find the median of that and what the first quartile is. And so this is that same example, that New York commuting time on it. If I were to go back and look at what our median was for that problem, that median, I believe, was between 20 and 25. It was about right here, because I think we said there was 20 numbers in here. Our sample size, I believe, was 20 for it. And so I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. So our median was between 20 and 25. We had to add them together and divide by 2 for it. And so when we're going for this, what we're going to do next is we're going to find the median of the lower half. And that's what the first quartile is. It's the median of the values to the left of the median, the observations to the left of the median. So I'm going to look. I had here 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Right here, if I split these in half, that's where my quartile 1 is going to be. It's going to be the average of those two numbers. Well, the average of 15 and 15 is 15 on it. So you're still going to take those two numbers and divide by 2 as well. And then we said there's 20, so we have 10 over here. So 1, 2, 3, 4, 5. It's going to be right here between these. So for quartile 3, I'm going to take 40 plus 45 and divide by 2. Now it's going to give me quartile 3. This gave me quartile 1 on it. I have my quartiles. 42.5 for the third quartile, 15 for the first quartile. So therefore, our IQR is 42.5 minus 15. And in words, the IQR is 27.5 minutes, context. And it is that value. It is not our IQR is between 15 and 42.5. No, IQR is 27.5 minutes. If you want to interpret it, always be ready to interpret your values. The range of the middle half, the IQR represents between the first quartile and the third quartile. That's 50% between the 25% and the 75%. 1 quarter, 3 quarters. Between 25% and 75% is 50. So the middle 50%, the middle half of travel time for New Yorkers in the sample is 27.5 minutes. That's how you interpret the IQR. The middle half of the data, the travel time, the commuting time for New Yorkers in the sample is 27.5 minutes. And so here's another one kind of going through with that McDonald's one very briefly. You can see this one was our median, and since this was our median, we're not going to use it. We want the values to the left of the median, the values to the right of the median. And so here is the middle of the ones to the left. Here is the middle of the ones to the right. The IQR is not from 19 to 39. No, the IQR is 39 minus 19. It is 20 grams of fat for it. So again, IQR is a value. It is not a range. So identifying outliers on this one. So this one becomes, now we did center, we did spread, shape didn't get affected at all in this lesson. So now we have outliers. So if I were to quickly make this list, shape, outlier, center, spread, this is in 1.2. Okay, we've done center, we've done spread a little bit. Let's focus on outliers. Outliers use IQR when you're trying to find them for it. And what the definition is we're going to use the 1.5 IQR rule for outliers. Any observation that falls more than 1.5 times the IQR, 1.5 units times the IQR above the third quartile or below the first quartile is considered an outlier. So when you find your quartiles, you're going to find your 1.5 IQR value. You're going to find your IQR multiplied by 1.5, add it to the third quartile. Anything above that value is an outlier. Subtract it from the first quartile. Anything below that value is an outlier. And so we have the same data we've been dealing with. It's the same exact numbers we've had before. So we found our first quartile. We found our third quartile in the previous slide. We found our IQR, 27.5. So now we do the new work. Now we go ahead and find what is 1.5 IQR. So I'm going to take 1.5 times the IQR value we found in the previous part of this problem, and that's going to give me 41.25. The IQR is 1.5 times the IQR is 41.25. I'm going to take that value. I'm going to subtract it from my first quartile. So my first quartile, previous slides we looked at this, was 15. So if I do 15 minus 41.25, negative 26.25 minutes, that doesn't make sense. There is nothing that is going to be shorter than negative 26.25 minutes. If I look at Q3 plus 1.5 IQR, I take that 42.5 and I add the 1.5 times IQR to it, I get 83.75. Any value that is longer than 83.75 is going to be an outlier. Any value shorter than negative 26.25 is going to be an outlier. So when I look over here at my stem plot, you can see I have highlighted here that 85 is an outlier because it is beyond that 1.5 IQR added on to Q3. It is beyond that 83.75. So we do have an outlier in this case. We can look at it with the beef sandwich examples from McDonald's. We already found all the information from before. We found our Q1, we found our Q3, we found our IQR. So I take, and I'll do purple here, I take this IQR, I multiply it by 1.5. That's going to give me how far above Q3 and how far below Q1 I go. And that's what this part is showing you. You take your Q1, subtract that value. So 19 minus 30, negative 11. Any value below negative 11 is going to be considered an outlier. It doesn't make sense with calories and fat grams on here. Q3, any value above 39 plus 30, 69 is going to be an outlier. If we look at that stem plot, we see there are no numbers that fit that range, so there are no outliers in this case for it. So now Mr. Nichols will go into how we're going to look at putting all of these together graphically with a box plot. But the main ideas that we went through today, and I'll come to this part, shape, outlier, center, spread. We examined how we can find these values specifically, and we focused primarily on center, we looked at mean, we looked at median. Now a spread, by the way, we only looked at, in this case, I'm right here, you can see we looked at IQR. That spread is linked to median. If you're going to use IQR, you're going to use median. If you're going to use median, you're going to use IQR. Those two are linked. In order to find IQR, you have to find median. So if you're going to tell me median, you tell me IQR for spread. We did outliers by calculating here. So we focused on the OCS and SOX on being specific on those. Hopefully this video helped. Mr. Nichols will continue on with how to use these values to create meaningful displays.